Okay, let's end today's lesson by talking about some of the types of errors and powers. Okay, here we have a situation. A company develops some new batteries with a longer life. Its regular battery lasts for 30 hours. They plan to test 15 new, use a significance level. What does power mean? Well, the power is the probability that the test will correctly reject the null hypothesis that battery life did not improve. Beyond 30 hours. Okay. When it has actually improved. So what we're looking at, if you think about it, the power of the test, right? We always talk about these four different things, right? The power of the test is when the null, we have the null is true, we have the null is false. In this case, the null is false. The alternative is that they have improved, and we want to correctly reject. So we would, check the wrong spot, right? This is null, we reject null, and this is our power of our test. The null is false, and we correctly reject it. That is the power. Remember, this is an error. This is the type 2 error. This is your type 1 error. And this is your, so this would be the null is true, but you reject it. The type 2 error is you fail to reject when the null is false. What are two things that we can do to improve the power of the test? Okay, so remember that there are actually three things, right, that impact the power of the test, or four things, right? As beta error goes down, power goes up. We have then the effect size goes up, power goes up. This is because power is equal to 1 minus beta. So if beta gets smaller, power is going to get bigger. Effect size goes up, the power goes up. If the alpha error goes up, power goes up. And if n, which is our sample size, goes up, power goes up. Okay, this is our B-E-A-N. Okay, so those are the things that improve the power of the test. But which of these can we actually affect? Well, he can come up with a better battery, but that's not really part of the testing. We can accept, so he has really three things. We can't, this would be more R&D. Sample size goes up. This is more testing cost. Then two things we could accept a greater risk of type 1 error. The downside of that is we are more likely to say improved when it is still the same. So that's not so good, because we've said we've got this new battery when we really don't have a better battery. We could also, this situation won't really happen, right? Because we're hoping to, this does not relevant, because we are hoping that we are actually going to reject, and so the beta error is only when you fail to reject. So really the engineer, the R&D is done, so these are really the two items that we can affect, and there's the downsides: more testing costs or greater risk.